Assalamualaikum dear students, hope you are fine by the grace of Almighty Allah. Welcome to NIEVS Home School. I am Sabreena Haque, Assistant Teacher of Science, National Adult English Version School, Day Shift. Dear student, today I am going to take a science class for class 8 student on the based on chapter 8. The name of the chapter 8 is chemical reaction. We know every time in around us and inside our body various types of chemical reaction is happening. Today we will discuss about these various types of chemical reaction and different types of elements and compounds. So let us move for our today's topic. Different types of chemical reaction are going on around us. Their chemical reaction are sometimes releasing energy, sometimes creating useful new materials, or sometimes helping cure diseases. Look, there in the laboratory, the scientists make the medicine, life-saving medicine, there is a reaction, and look, we the light from the candle, there also a chemical reaction. If we observe the bottle of the soft drinks, there also a chemical reaction. Every time and all around us and inside our body, outside our body, in the environment, lots of chemical reaction are happening. Now for understanding the chemical reaction, we will revise first the symbols, formula, and we will learn about the valency of the elements. Now in class 7 we have get some ideas of symbols and formulas, and according to structure, chemists have divided all the substance of the world as elements and compounds. What is elements? Which things if we break that time, after breaking we will break only that things that is the any element, and if we break the compound we will get two or more elements. That means two or more elements joined together to form a compound, and till now 118 elements have been found out. And generally this is the definition of symbol. Symbols are expressed by the first one or two letters of English or Latin name of the element. The short expression of elements is called symbol, like hydrogen H, oxygen O, calcium Ca, that is the symbol. Now the short expression of molecule of compound and element, there is not written about the element. The short expression of molecule is the formula that may be for compound, that may be for the element. For example, the formula of hydrogen molecule is H2, that is not written properly, that you have to write like this, H2, the 2 will be as suffix, then O2. And hydrogen chloride molecule HCl, oxygen, we can write H2O, that all the formula of hydrogen molecule, oxygen molecule, water molecule, and hydrogen chloride molecule. To write the formula of compound, we need to know the valency of the element. According to the number of valency of the elements from compound by chemical bondage, we can compare the valency of the element with our hand. Then the element having valency 1 means it has one hand. Hydrogen and chlorine both are one-handed elements, so their valency is 1. Therefore, the formula of hydrogen chloride and the valency of oxygen is 2. That is, for HCl is the formula of hydrogen chloride and the valency of oxygen is 2. Look, one hydrogen can hold only one chlorine because both of their valency is 1. That means they have one hand. They had one hand, and with that one hand the chlorine can hold one hydrogen, or the hydrogen can hold one chlorine only. And look here, the oxygen has two hands. It can hold two hydrogen atom, that means oxygen valency is 2. Look this ammonia picture, nitrogen can hold 3 hydrogen atom by its 3 hand, that means it has valency 3. Look in the methane, carbon hold 4 hydrogen with its 4 hand. This figure shows that the carbon's valency is 4. Therefore, the valency of the elements means the number of hydrogen atom attached to that element at the time of formation of a compound. This is the definition of valency. It is to be considered that all the hand or the valency of an element are satisfied. Now, look, this is the Valency table. There you have to memorize that for your MCQ. Non-metals valency, hydrogen and fluorine, bromine, chlorine, bromine, iodine has 1 valency, oxygen, sulfur, carbon has valency 2, nitrogen, phosphorus has valency 3, carbon has valency 4, sulfur has valency 4. If you observe, there some elements have the variable valency, that means they have the valency more than 1. Look, this is the metal, and valency 1 is sodium, potassium, copper, silver, gold. Valency 2 is calcium, magnesium, zinc, iron, copper, tin, lead, and valency 3 aluminum, iron, gold, and valency 4 is tin and lead. And here also some elements, some metals has variable valency. And come to the radical. Then what is radical? When a group of atom in the time of chemical reaction behave like one atom, that group of atom is known as radical. There is some radicals and their valency. Ammonium hydroxyl, nitrate, nitrite, bicarbonate, all radicals have valency 1, and their plus minus shows their charge and charge number. Now come to the carbonate, sulfate, sulfide, that radical group has valency 2, and phosphate group radical has valency 3. In the above table, that groups of atom do not stay independently and they participate in compound formation like elemental atom. This group of atom is called radical. The two line write the molecular formula of the following rules are to be mentioned. First one, if the valency of the element or radicals is same, it is not necessary to write the valency in the formula. So only the elements and radicals are to be written together. For example, calcium oxide, both oxygen and calcium both valency is 2, so no need to write their valencies. If you are thinking about carbon monoxide, carbon and oxygen, their carbon's valency also 2 and oxygen valency also 2. So in carbon monoxide we only write CO, that means no need to write of their valency. Ammonium chloride, here the ammonium valency also 1, chlorine valency also 1, that's why we only write the radicals formula and the chlorine. Now come to ammonium nitrate, both of their valency is 1, so we only write 2 radicals together. Now come to the second rule. The valency of one element is multiple of the valency of another element. The valency of both elements is divided by that multiple. If you think about the carbon dioxide, we have to write the CO2 here. We are always write CO2, and there is a rule, that is the oxygen valency will be written with carbon and carbon valency will be written with oxygen. Here 2 is the valency of oxygen and 4 is the valency of carbon, but both has the common multiple 2. By dividing both of them we will get CO2. Here the valency of carbon and oxygen, carbon dioxide respectively 4 and 2. Last rule, if the valency of both element is different but not any multiple, like valency A is X and B, valency of B is Y, then the formula is of the compound formed with A and B is AYBX. The valency of the element A is written at the suffix on B and the valency of element B is written at the suffix of A. For example, Al2O3. Here this 2 is the valency of oxygen and this 3 is the valency of aluminium, and that is written valency of oxygen written with aluminium and valency of aluminium written with oxygen. That's why we are writing here Al2O3, aluminium oxide. Formula is like that. Now come to the lesson 3 and 4, that is chemical equation. To describe the chemical reaction, we need to know about the chemical reaction. A chemical reaction can be divided into two parts. One part contains the reactant and the other part contains the product or the newly formed substances. Look, sulfur and oxygen, both are reactant. That part is known as reactant, and that is the product. Sulfur and oxygen become sulfur dioxide through the chemical reaction. Reactant represent the pure stage of the reaction and product is the resultant stage of the chemical reaction. In any chemical reaction, atom cannot be created or destroyed, but they are rearranged only. The total number of atoms present in the reactant before the reaction always equal to the total number of atoms or the product after the reaction. Look, there one sulfur atom and two oxygen atom. Here in the product there are also one sulfur atom and two oxygen atom. That should be maintained. That means that balance should be maintained. We have to remember that no atom will be created and or destroyed, only they will be rearranged. So the reactant after their product have the same number of atoms of a specific element. In the light of the above discussion, chemical equation may be defined as below. This is the definition of chemical equation. Chemical equation is the shortened expression of chemical reaction. It uses some symbols, formulas and some mathematical signs to denote the reactant and product. This is the example of chemical equation. Zinc plus sulfuric acid react with each other and produce zinc sulfate and hydrogen. Here one zinc atom, two hydrogen atom and one sulfate radical. Look that only hydrogen is get separated and zinc sulfate zinc react with produces the zinc sulfate with the sulfate radical, and this there also one sulfate radical, one zinc molecule and two hydrogen molecule. That means two hydrogen atom and one zinc atom, one sulfate radical and two hydrogen atom. The number of atom left side and right side are equal. That is the condition of the chemical equation. Now come to the rules of writing the chemical equation. In a chemical equation, the formula or symbols of the reacting substances or reactant are written on the left of the sign of equality, and the symbol or formulas of the products are written on the right of it. Second one, if the reactant or products are more than one, a plus sign and is put between the formula and the symbol. Now come to the third rule, that if the number of molecule is more than one, then the number is used before the formula. Now next rule is an arrow sign is used to indicate that reaction moves towards the product from the reactant. Instead of an arrow sign, the equal sign may also be used. However, the equation has to be balanced on both sides. Now come to last rule, the number of atoms of different elements present in the reactant before chemical reaction must be equal to the number of atoms of the different elements in the products formed after the reaction. So to make the balance, the symbol or formula must be multiplied by the required number. Come to the balance. How we will make balance in chemical equation? Hydrogen react with oxygen to produce water. Look here, right side, one hydrogen molecule, one oxygen molecule react with each other, produce water. If you observe here in right side, left side, two hydrogen atom, two oxygen atom, but here in the right side, two hydrogen atom, one oxygen atom. Because this shows that they are not balanced. For making these two oxygen atom equal, for this we have to put here 2, before the water formula of water, before the molecule of water. And for these two, that means we have to give at least 4 hydrogen atom. For here we have to give here also 2 before the hydrogen, then in the both side the number of atom will be equal. How? There they show it here, 2 into 2, that means in H2 that there is 2 hydrogen atom, that means there is 4 hydrogen atom, and here in of O2 there is 2 oxygen atom, and here also 2 into there 2 hydrogen atom, 1 oxygen atom, that's 2 into 3, total 6, here also total 6, that means in left side and right side the number of atom will be equal. Now we will learn about the different types of chemical reaction. First chemical reaction is addition. Then understanding this addition reaction, we have to do our exercise: test tube, mortar, spirit lamp, burner or iron powder, sulfur and balance. Then methodology: properly clean the test tube and dry it using balance measure 1 gram iron powder and 4 gram sulfur, keeping the ratio different amount of iron and sulfur can be taken, and grind them together in the mortar. Put the powder in the test tube. Now heat the bottom of the test tube using the flame low while heating. When the mixture in the test tube become red hot, stop heating. Keep the test tube above the mortar so that in case of the test tube breaks, the materials in it will not be spoiled. And after cooling, the test tube breaks and it to separate out its contents. The materials that obtained from the test tube will look deep grey, and you will see that light yellow sulfur or iron in it become the iron powder, and the sulfur chemically combined produce a new material, ferrous sulfide. And look, iron and sulfur react with each other and form ferrous sulfide, and this type of chemical reaction in which more than one element combine to produce a new kind of chemical substances is called synthesized substances. And all synthesized reaction are addition reaction, chemical reaction. All synthesized reaction are addition chemical reaction. That means in addition chemical reaction, one and more element combine to produce a new kind of chemical substances. Look here, zinc and sulfur react with each other, produce zinc sulfide. Here two elements join each other and combine each other and make the one new element. This is the synthesized reaction or addition reaction. Now come to the combustion reaction. In a combustion reaction, a substance reacts with oxygen from air at high temperature, and for this activity we have to follow observing the combustion reaction between the sulfur and oxygen. A combustion spoon will long handle some amounts of sulfur, spirit lamp and a burner. Some methodology: take some sulfur in your combustion spoon, go on heating the spoon with the flame of your burner. What do you find? First, you will see sulfur to melt, and then you will see the blue flame and smell a pungent smell. This is because due to the heating of sulfur, it chemically react with oxygen in the air and produce sulfur dioxide gas, which gives a pungent smell. The sulfur plus oxygen produces sulfur dioxide. And again I am saying the definition of combustion reaction. In the combustion reaction, a substances react with oxygen from air at high temperature. Now come to the substitution or displacement reaction, and here observing the reaction between iron and copper sulfate. Necessary compound: iron powder, copper sulfate and water and test tube. Now the procedure: fill the test tube with water to 1/4 its volume. Take some copper sulfate in it and shake to make a solution of copper sulfate. Now put in some iron powder in this blue solution and copper sulfate and blue solution of copper sulfate and shake Thoroughly. Do you find any change? The blue color of the solution gradually turns into green and small particles are forming at the bottom of the test tube. Why the blue color of the solution turns green? Here the chemical reaction takes place. As a result, ferrous sulfate and copper have been formed. The color of iron sulfate is light green, or ferrous sulfate is light green, which turns the blue color of the solution into light green. Like that means iron plus copper sulfate. Here copper is displaced by the iron and it makes ferrous sulfate and copper, and in this reaction the iron is removing copper from the copper sulfate and occupied its place and to form the ferrous sulfate and pure copper. This type of chemical reaction where an element replaced another element from a compound and compound band occupy its space producing a new compound is called displacement reaction. Now come to the decomposition reaction. Decomposition reaction just opposite of addition chemical reaction or synthesis chemical reaction. And then what is chemical decomposition or chemical breakdown? That is a process or effect of the simplify a single chemical entity into two or more fragments. Now come to observing the decomposition reaction of limestone. Necessary component: limestone spatula or spoon, test tube, lime water, outlets tubes and Bunsen burner or the spirit lamp, clamp stand, cork and hand gloves. Methodology: wear the hand gloves and with the help of spatula take 5 grams of limestone in the test tube. Now heat the bottom of the test tube with the flame of the burner. Observe very carefully. Carbon dioxide is being produced. The limestone which was taken in the test tube decomposed into carbon dioxide gas and formed the calcium oxide due to heating. Loop: one compound is taken and by applying heat it produces two compound, and that is the decomposition or the chemical breakdown. That means it is the just opposite of chemical reaction of addition. Now you can examine whether the gas is carbon dioxide. Take 1 to 2 millimeter of lime water in the other test tube and fixed fixed like this way. After fixing this, through this tube pipe, the carbon dioxide gas will go to the lime water and this lime water will become opaque. That means it becomes opaque, and that means that carbon dioxide react with lime water and produce the calcium carbonate and water, and that procedure is known as the chemical decomposition or decomposition reaction. Today we will learn 4 type of chemical reaction: addition reaction, then combustion reaction, then substitution or displacement reaction, and lastly we learn about the decomposition reaction. Dear student, we have finished our today's topic. Hope you have understood this chapter is too much important for you. Read the chapter again and again. Thank you. Allah Hafiz.